Hey guys, and welcome to Functional Print Friday, and welcome back to my shop. So I want to do something outside this week. A couple of months ago, I helped a neighbor sink some 6x6 posts into the ground to build a bunch of pull-up bar stations. And I've been meaning to go back and trim those posts ever since. They're all at different heights at the top. Basically, I got recruited for this because I've got a tractor with like an auger on the front that makes digging the holes for those posts a lot easier, but you never get everything at exactly the same depth. And I think we had some of the posts cut to different lengths as well. So long story short, the posts are not even heights at the top. I want to trim those, but I got to thinking about it, and we want this to last a long time. And I'm thinking that with the open end grain on the top of those posts, there's a lot of water that's going to seep in over time and cause those to decay faster. Yeah, they're pressure treated posts, but they're going to last even longer if we can keep water from getting into them. So I think this coincides well with something else I've wanted to try. Bamboo Lab has released a new filament, PETG HF. I think the HF stands for high flow, although I can't actually find that anywhere on their website. It just says HF and talks about how you can print a lot faster with it than normal PETG. I've heard good things about this. I want to try it myself, so I actually picked up 2 boxes of this. And I think this is going to be a great test for it because not only are we going to get to see print quality, but we're also going to see how this stuff holds up outside. These are going to be in a tough environment. They're going to get sun pretty much all day where these posts are. You'll see. We'll walk up there. And they're going to be exposed to the elements as well. Now I'm in Pennsylvania. We don't have weather here as hot as say people get in Florida or in other parts of the world where it's a lot hotter, but we do get some pretty hot days here. It gets over 100 degrees at least a couple days a year, and we get very cold winters, and we get pretty big temperature fluctuations throughout the year as well. So I think that's going to be a great test to see how this stuff holds up over time. You guys keep me honest. If you're watching this video in the future and you look and this video was published like a year ago or 2 years ago or 3 years ago, hey, throw me a comment down below that says, hey Rich, how are these doing? And I'll go up and take a look and keep you guys posted. Maybe we'll even do a follow-up video. But for right now, let's walk up and let me show you the posts that I want to make covers for. All right, so here are those posts, and these are 6x6 pressure treated posts. I want to do 2 things. I want to trim the top of them so that they're all even because it doesn't really look too good them all being different heights. Now these 2 over here are genuinely shorter, so we'll probably trim like these 3 to the same height and then these 2 to their own height that at least they match each other. And I want to design caps that sit on the top of these because that's going to be, I think, the first spot on these that really starts to I guess weather over time. Now they're pressure treated, they're going to last a long time, but capping them is going to make them last even longer. So I think I'm going to design a 3D printed piece to help act as a guide to trim these too. I got to think about that. I have an idea, I'm just not sure if it's going to work. So I'm going to get some measurements of these and I'm going to start drawing. All right, and here is the design that I came up with for these. And we're looking at this basically upside down. This is the inside of the cap. This is going to be what actually fits over the top of the post. And the reason for the 2 recessed square shapes in here are just to give us better adhesion onto the top of that post. I'm going to use probably like a polyurethane outdoor construction adhesive for these. And I think just by having these extra sort of grooves in here, it's just going to give it more to grip onto. 3D printed plastic, PETG, PLA, doesn't matter what it is, it's like notoriously hard to glue to. So anytime you can give it some extra surface area to grip, it's always a good thing. We're going to print this on this face. This thing is swept back a bit, that's so that water drains off of it. But the angle isn't so much that it's going to mess with our sides if we actually just print this as the face that goes down on the bed. So this face and this face will print at a bit of an angle, but that should be fine. It's probably no more than, I don't know, maybe a 15-degree angle, so it should print with no issues. This is the front, this is the tallest face, and the reason why it is recessed like this is I want to laser engrave the front of this. I want to put a neat design into this for my neighbor that I think fits with the work that he does in his yard. All right, enough talking about it. Let's go ahead and get one of these printed and see how it looks. All right, guys, the first one is done, and so far I am really impressed with the print quality. This is as good, if not better, than PLA. Now, I did dry the filament first, per Bamboo's recommendation, and I don't usually dry my PLA before I print. So, you know, I think we'd probably need to print this in PLA and dry the PLA first as well to get a fair comparison. But this thing is clean. Bed adhesion was really good. You can see from the even surface finish on the bottom that there was no lifting, and this was not printed with a brim. And it has a 45-degree chamfer all the way around, which, you know, I found sometimes helps with bed adhesion by reducing some of the tendency of it to lift at the corners, and in other prints it seems to make it worse. But in this one, I mean, yeah, that's, as you can see, that looks really good. You know, I added this feature down here to help retain this onto the block, just to give the glue more surfaces to go into. Probably didn't even need to do it. I didn't think about the fact that by printing this guy with this as the face down, that we'd have this nice stepped feature in here, which, you know, you call that ugly from a surface finish perspective, but we're not going to see it. It's going to be, you know, inside underneath, and it's going to give us a lot more rough edges for that glue to stick to. So I think that accidentally ended up being probably one of the best features of this this design. So, all right, I am going to print 4 more of these, and I'll bring you guys back. All right, all 5 of these are done, and there's a reason why I laid them out in that specific order, because I noticed something interesting as I was printing these. So if you recall, when I said I printed the first one, the layer adhesion was really good, no issues. It self-released from the bed when it cooled down. In fact, this one, I guess this one did sit for the longest amount of time. This print finished overnight, and when I came down the next morning, I just gave it a little shove from the edge to see if it was still stuck to the bed, and it had completely self-released. It just slid, no problem. As I printed these, bed adhesion kept getting better. I don't remember if there was really a significant difference on the second one, but by the time I got to the third one, it was no longer self-releasing. Even after it cooled down, I still had to sort of pick up the edge of the sheet, and it popped right off. It's not like it was, you know, overly stuck to the bed. And by the time we got to the last 2, you can actually see, it seems as if it was kind of cleaning junk off of the bed. It was adhering so well. Again, even the last one, it didn't self-release when it cooled down. I did have to pick up the end of the plate, and then it popped loose right away. So it's not like it over-adhered. But yeah, you can see it's almost like the PETG combined with whatever material they put in here started to like pick up junk that was on the bed. And I'm not sure what this is about here, this round part in the center. Maybe it's cleaning, maybe it's picking up some of the material that was left over on the bed that was PLA. I do print mostly PLA on the P1S that these came off of. So, but I just found that interesting. Like, there is no difference in the print settings between these two. But you can see this one clearly was picking up something from the bed and was adhered even better than our first print. So, all right, these are looking great. I mentioned when I talked about the design that this inset on the front here is intentional. I want to do some engraving on here for my neighbor. So I think it is time to get the laser moved over into this spot and show you guys that machine. I've used it in a couple previous videos and not revealed what it is, but it is time to show you guys. So let me clear this up and I'll bring you back. All right, and here it is. This is the Monport GA30 MOPA fiber laser. Now, I know that's a mouthful, but I'm going to talk you through what those different things mean and why I specifically wanted a fiber laser and why I wanted a MOPA fiber laser. So if you remember a couple of weeks ago, actually probably a month and a half ago at this point, we made this tension wrench for my bandsaw, and at the end of the video, if you guys hung around to the very end, you saw me come out of the closet with this this engraving here on the wrench. And this is the machine that I did this engraving on. And the reason why this is so cool is because normally you cannot engrave on plastics with a laser. I have tried it in the past, even though, you know, I had read that you couldn't, and the results I achieved are probably the same that you have achieved if you've tried. You end up basically just melting the plastic. This was my attempt with the Creality Falcon laser to mark on plastic, and whether you do it at the highest power or lowest power, all that it accomplishes is just melting the plastic. And that's because even when you're applying high power for a very short period of time, the actual amount of time that power is applied to the material relative to what a fiber laser can do is just quite high. And you always end up melting the material. You can see in every attempt made here, regardless of the speed or power, all we did was melt the plastic. Now, what's unique about fiber lasers is, well, there's a couple different things that's unique about them. The wavelength of the light is different, which also helps us a bit in this case because we can actually vaporize the ink or the dye out of the plastic. But the big difference is fiber lasers, you can control the frequency. You can control how you deliver the power with a lot of precision. And MOPA takes it a step further. MOPA is MOPA, Master Oscillator Power Amplifier. And the actual description of what that does is pretty technically complex, and I might dig into it in a future video because it is pretty interesting. But in short, the value you get out of a MOPA fiber laser is you get even more control over delivering a tremendous amount of power in a very, very short amount of time. Basically, you can run this at a high frequency and with a very short pulse width and still deliver the full power of the laser for a tiny amount of time. And that is how you achieve these results. This is a combination of hitting the surface of the plastic with so much power that it actually vaporizes the dye in the plastic, as well as basically kind of foams the material on the top. It doesn't melt the plastic. It hits it with such intensity that it kind of foams. And then the combination of it foaming and eliminating the dye gives you this beautiful effect with really, really high resolution. So let me get you out of the tripod. I'll show you around this machine a bit. So this machine follows the build format of a lot of different fiber lasers where you either have the actual laser source in the base, or you have it in sort of like a side piece that looks like a small desktop computer almost, that goes alongside. I prefer this style where the laser source is in the base because you end up with a really nice heavy base that just makes the machine a lot more stable. This has a JPT M7 laser source in it. Most of the fiber lasers that are out there on the market are either a JPT or a Raycus. They're both good laser sources. The JPT M7 is known as one of the better MOPA fiber laser sources. And this machine is no exception. The testing I've done with it so far has been very impressive. Now, that testing has also not been without some challenges. And to be fair to Monport, those challenges are not their fault. This machine arrived very well packed in a really beefy crate, but unfortunately that crate must have been dropped or just really mishandled at some point because there was a number of things, there was some damage that this machine took in shipping. The arm down here at the hinge was bent a little bit. This had come misaligned from the gantry that lifts up. I was able to correct most of the issues, but I think there's still something going on inside with the actual galvanometer. The way these machines work, if you're not familiar, is rather than the actual laser moving around on a gantry, like you would have on the typical diode lasers that you see and that we've reviewed on this channel in the past, the laser beam is basically steered around by, I think, 2 mirrors in here on little very fast servo motors, for lack of a better way of describing it. So this stays stationary, the base stays stationary, the laser beam actually gets steered around on the surface. And I think something just got misaligned in there because I'm not getting as good or as even of performance on this as I should. But we're going to work around that because I do really want to show you guys this machine. And I'm working with Monport. They're either just going to replace this unit altogether or send out a new unit up here at the top that has the galvanometer correctly aligned. Now, one of the really nice things about this particular machine is that it has autofocus. All you have to do is just push this button, which is not going to do anything right now because I do not have the laser source turned on. But if I did, you'd see another little focusing laser here in the front, and you put your workpiece underneath that, and it actually automatically moves this gantry up and down and finds the perfect focus point for the laser. Now, you can also manually adjust it, but I haven't had to. They marked on the side here 322 millimeters. So you measure from whatever surface you're engraving to this red line, and I have auto-focused on a number of different materials and then checked it against this line, and it's always like dead on. So I'm not exactly sure how that focusing system works, but it does work really well. All right, enough talking about it. Let's actually do something with this machine. This is not a review video. I just wanted to give you guys some basic information because if I don't, you're going to ask me down in the comments anyway. I will take a more in-depth look at this machine at some point in time in the future. But I do want to add one more thing. This machine's biggest advantage is also its biggest downfall. It'll explain on its own why it's an advantage, later on in this video, but right now, if you guys are not already screaming at me down in the comments saying that this machine is not safe because it is not inside an enclosure, yeah, you're 100% right. I agree with you. It is not safe to use a laser like this without an enclosure. Sure, I can put my safety glasses on and I'm safe as long as I have the laser source turned off whenever I take my safety glasses off. And you guys are safe because this is just a video and there's no light that's going to come out of your screen that's going to hurt your eyes. However, it is not safe for anybody that would happen to walk into this garage. I mean, I just counted, there is 6 doors into this garage, between the 3 garage doors, 2 entry doors, and the door that goes up to my office upstairs. So there are plenty of places for someone to walk in while I'm using this machine and potentially get their eye struck with, a stray, reflection of the laser off of whatever I'm engraving. And, that's a serious eye injury, potentially an incident that could blind you. And you've got to take that seriously. Now, I have rectified that kind of. Hey, this is a 3D printing channel and I don't have an enclosure. So you guys can probably guess what I did here, right? Well, if you guessed I spent the least amount of time possible building an enclosure from a cardboard box, give yourself a pat on the back. I may actually design a 3D printed enclosure for this at some point in time in the future, but this gets the job done for now and makes it much safer to use this machine for anybody that might walk into the garage while I am using it. But hey, come on, give me some credit here. It's even got magnetic latches here on the door. By the way, this window here is a story in and of itself. We'll cover this in a future video. This is just some orange tinted acrylic and it does absolutely nothing. I know because I tried engraving through a piece of it and it did nothing. So we're going to replace this with something else. But for now, you can see this is functional. It's not great, but it's functional. We are still missing one thing we need for safety though. Hold on. All right, the machine you just saw me connect there is a fume extractor, and you do not want to operate any type of laser, fiber laser or otherwise, without some sort of fume extraction. Because when you're vaporizing material, which is what these lasers do, you often are creating other compounds that even if the material you're engraving is safe, the compounds that you create when you vaporize it, they're probably not. You do not want to be breathing that stuff. This is the Acmer AP220. It's a really nice portable unit, has a timer on it, and what I really like about it is when you turn it on, you can control the amount of airflow. Like you have it pretty low, almost to the point where it stops, or crank it all the way up, and it moves a lot of air. Oh, and a quick shout out to these guys, because Acmer reached out to me forever ago and asked if I would test one of their diode laser cutter engravers, and I said, no thanks, because I've already have a machine like that and it's just not going to add any capability to the shop, and I'm just not interested in looking at something if it's not going to add a capability to, my set of maker tools. And I wrote them back at some point in time later and I said, hey guys, I don't have a fume extractor and I need one for some upcoming projects. If you send me one, I'm sure it'll show up in a video at some point. And they sent this one out and I'm honestly really happy with it. If someone stole this out of my shop, I would just buy the same one again. It's really powerful for its size. I think the only use case I would not recommend this for is if you're doing a lot of really, really heavy cutting engraving. I think you're just going to fill up the capacity of this guy and the filters pretty quickly. But if you're doing the type of work like I'm doing, where you're doing more engraving and marking, where you need to capture those those tiny particles that you're generating in that smoke, this machine is great. I'll link this down in the description of the video. And that terminates inside the enclosure here with a genuine lock line fume extraction pickup that I bought. That's the blue and the orange piece that you're seeing. These lock line ones are kind of pricey, but they're really worth it because they hold their shape so well. I'll link to that down in the description as well. All right, let's get started. The first thing I'm going to do is show you how I did the engraving for the wrench. I've got a scrap piece of PLA. I'll get that in here. I'll get the camera set up. I guess we'll do this with this door open because this door isn't doing anything anyway. I'll just make sure my safety glasses are on and I'll get the camera set up so you can see the actual engraving process because it is nuts how fast it does it. All right, this is just a scrap piece of PLA plastic. You probably recognize it actually as one of the test pieces that we made in doing the 3D printed blast gate from a couple of weeks ago. So what I'm going to do is I'm going to position this material underneath this front little laser dot, and I'm going to hit the focus button. And what that's going to do is move the gantry up and down and focus the laser so that it is the right height for the top of this material. All right, with that done, we can slide this over to sort of the center of the work area here, and I'll show you the next really cool feature of these Galvo style lasers, because what I'm going to do is I'm going to turn a preview on. These beams here are perfectly safe. These are, actually probably less power than a typical laser pointer. But what we're going to be able to do is actually draw the outline of what we're going to engrave with the Galvo head using just these sort of laser pointer power lasers. So hold on, let me turn that on. All right, and with that turned on, you can see that it's actually sort of drawing a rough preview of what it's going to engrave now. And that's really useful because we can slide our workpiece around to position this. And that's how I got that engraving on the wrench to be in the perfect inset that we had 3D printed in the wrench. So I'm going to position this up towards the top of the workpiece so that we have room to do it again in case something goes wrong with filming this. So, all right, you're going to see this guy start engraving, and it is pretty quick. All right, it's done. I'm going to turn the laser source off here so I can take my safety glasses off and know that I am safe. And if I pull this out and lift it up, now that was 8 passes on this. I found the more passes that you make, the more durable the mark is, or the deeper in the material the mark is. At 8 passes, I can even push on this pretty hard with my fingernail, and I am able to sort of smooth the plastic a little bit there and mark it if I push real hard like that, but it is pretty durable. And I don't know if it's showing up on camera, like just how high resolution and clear that marking is. All right, that's probably giving you guys a better view of that. And the level of detail is just insane. And that is why I wanted one of these machines, was to be able to do marking like this on plastic that you just can't achieve, even with like an AMS on one of the Bamboo Labs machines. I would never get this quality of resolution or be able to do print or design this small. I mean, these letters are huge. We could have done these 3D printed. That wouldn't have been a problem. They wouldn't be as sharp as they are, marked like this with the fiber laser. But there's no way that we would have been able to do this geometric design. That just would not have shown up, maybe with a 0.2mm nozzle, but it would have taken an eternity. Meanwhile, this thing marked in a matter of a couple of seconds on the laser. It also really enables you to maximize your workflow for functional parts that you also want to have markings on. So if we were doing this functional part and we wanted this marking on here, we'd have 2 choices. Either we could iterate the functional portion of it until we had a good fitment, and then, even though it was perfectly good from a fitment perspective, we'd still have to print it all over again with the engraving, and it's going to take an eternity to print this. You could do the engraving while you're iterating it, but then every single iterative print would take an eternity. This way, you can work on your design separately, run it on, say, a test piece of material like this, like a piece of scrap, and then engrave your final iterated design part and have things a lot faster. All right, I wanted you guys to see that because I never did show you how I did the engraving on the wrench, but let's actually get to engraving the parts that we're focused on in today's video. Let me get you back in the tripod. Okay, so here's one of the post caps that we have to engrave. We're going to engrave into this area that we relieved here in the design. Now, the trick is in this case, we're not engraving on either a top or a bottom surface. We're engraving on a side surface. We have all these layer lines, and that may affect how this engraving works and the power settings that we need to use. So rather than use just a flat like scrap of PETG, I actually went and I printed 2 of sort of just this front portion so that we can actually test the engraving on. Okay, so here's one of those test parts. The idea again being that we're actually testing the engraving on stacked layer lines that match our finished part versus, just printing on a flat top or bottom surface. So let me get this set up in here, get my engraving set up, and we'll test this. Okay, we're using that preview function here again to line up the outside bounds of our design inside of our inset there in the test part. That looks pretty good. Oh, you know what? I totally forgot. We actually have to refocus this. This is going to be a different height than our test piece we just did. All right, we're focused. Let me turn my framing back on. We'll get this guy realigned, and then we'll do a test on this with the same settings I used for PLA, just one pass, and we'll see how that looks. All right, those are supposed to be flags on the side, and the center didn't really show up at all. So that didn't work out too well. I might have to invert the design on the flags. Let me mess with this for a few minutes. All right, I think I've got everything worked out for this. I have my second test piece in here. I resized the stuff that we're actually going to engrave a little bit to make it more visible from down on the ground, and I've adjusted my engraving settings. I think we're there. So let me hit go. Let's see what we get. All right, I did 8 total passes on this. That is probably overkill, and I'll probably turn down the number of passes for the actual pieces that we're going to engrave, but I am really happy with how that came out. Let me get you out of the tripod, I'll get you a better look. All right, here is our finished test piece, and I gotta say, I think that looks absolutely outstanding. This is nice and sharp here in the center, and these weathered flags. I was really concerned about how these were gonna show up, being laser engraved with this weathered look, but I think they look great too. So I think we're ready to move on to engraving our finished pieces, but I think we're gonna run into a challenge doing that. Let me show you. All right, so here is our finished part, and can you guess the problem? Yeah, it's too darn tall. The gantry does have a fair amount of height adjustment on it, but not that much. It has probably about 2/3 that much. And that's not exclusive to this machine. That's a problem you're going to run into with just about any one of these fiber laser engravers. Is you just can't engrave objects that are this tall. But remember when I said this machine's biggest disadvantage is also its biggest advantage? Yeah, let me show you. Okay, so as you can see, I've gotten rid of the safety enclosure. And yeah, I know that's less than ideal, but there's a reason why I did it. And I've also loosened the 4 machine screws that tighten up this ring here on the bottom of the gantry. Can you guess what I'm going to do next? Yeah, this entire gantry can now be swung over the side of the machine, meaning that I can engrave now down here on the surface of my workbench. And in fact, really I can engrave any height material now, because I didn't just pick up this distance. If I was to move this machine over to the edge of my workbench, I can essentially engrave on something of any height. I would just need to adjust the height of my workbench or get this machine up higher, and I can pretty much put any object down here now to engrave, which means we should have plenty of room to get to the correct focus height for this. So I am going to need to grab like a weight or something just to hold this in place, but let me do that and get set up, and we'll go ahead and actually engrave one of our finished pieces. All right, so I actually rotated this back around a little bit. I think that's going to be a good position for us to be in and still have room for my laptop here. So you can see I've got this set up under our focusing beam, so I should now be able to actually autofocus on this to set our height. All right, and you can see we're actually fairly near the top of the gantry, even with this sitting down here on the desk surface. So there was just no way that it was going to be able to focus on it up here on the bench top. So that, again, like I said, I think that is this machine's biggest advantage. Yeah, you got to do it without an enclosure, or we'd need a giant like tent as an enclosure. But how cool is that for flexibility to be able to engrave on large objects? All right, let me get you down the tripod so you can get a better view of the actual engraving process, and I need to get my safety glasses on, and we'll get this kicked off. All right, I actually stopped this after just one pass because I don't think we need any more. I upped the power a bit on this, and honestly, at just one pass at that power level, I think that's looking pretty darn good. So I'm going to go ahead and get the other ones positioned, and we'll run all these parts, and I'll bring you guys back. All right, I think all 5 of those came out really nice. They all look exactly the same. It is time to go ahead and get these installed. And we're going to trim those posts as well before we install these caps. I actually made a tool for that as well, and this should be self-explanatory once we get up there. So let's get the truck loaded up and get up there and get started. All right, so here's where I'm at. I've set up a rotary laser on the back of my truck bed, and I've got the handheld part here. And what I'm going to be able to do now is come over here and mark the exact same height on all these. Not the height from the ground, but the height of level, because that's what we're going to use for this. Now, that's not necessarily the height at which I'm going to cut these, but it doesn't matter. It'll be the same point on all of them, and then I can measure up a set distance to get them all, well, to get these 3 at the same height and then to get those 2 at the same height. So I'm going to mark that position on all these posts, and we'll go from there. All right, so this last one I'm going to leave at the height that it already is, because I think that's already a good height. We're going to trim this one to basically match this one. It's 18 inches up from our line. The other ones are going to be 24 inches up from the line. And hopefully you can see what I'm trying to do here with this guide. Let me climb up. The idea is to clamp this in position below the line so that I can actually ride the fence of the saw on this block. Now, I designed this block with probably more clearance than it needed because I wanted to make sure it fit over all the posts, and it's a little bit too big. So hopefully it doesn't move. I've got it clamped on there pretty tight. I mean, I'll be able to see if I'm getting away from that line. And we're gonna have to cut from all 4 sides because unfortunately a standard circular saw is not gonna go halfway through a 6x6. So we'll have to come back probably with a Sawzall and just finish off the very center of each one of these. Yeah, and we can actually see now what this one's gonna look like. It's not glued on there yet, but you can see how it is pitched back so the water drains off of it. And you know, even though that engraving is fairly small, I think you can still make it out quite well from down here on the ground. All right, guys, these are done, and it's a good thing too because it is almost dark. These things always take longer than I think they're going to. I did make one mistake. I had originally marked this center pole at 20 inches, and then I decided to go to 24 inches on these 3. And you guessed it, I went by the wrong mark on the pole. So I ended up cutting this one further down to 18 to match these over here. So now there is 3 at one height and 2 at another height, which is always how it was going to be. It's just there was going to be 3 taller ones and then 2 shorter ones. Now it's just inverted. We've got 3 shorter ones and 2 taller ones. If anything, on this bar down here, that makes it a lot easier as you're doing a pull-up to see the engraving on there. So, I don't know, maybe a blessing in disguise. It'll be really interesting to see how this new PETG-HF filament holds up outside. I mean, Bamboo specifically calls out that it's great for outdoor use, so we'll see. And we're also going to see how the laser engraving holds up on the front of these as well. Guys, as always, thanks for hanging out with me for this week's design and build. Hopefully this was just as fun to watch as it was for me to do this project. And I'm really glad that we finally got to dig into the laser engraving and get a look at how that's done, because I'm really excited about the capability that's going to bring to the channel for lots of future designs where it's just not practical to do multicolor for some sort of design or marking on a part. And we've just scratched the surface with that laser. It doesn't just do plastic, it does other materials as well. So you're definitely going to be seeing more of that on the channel. If you have any questions or if there's anything you would have done differently, please feel free to let me know down in the comments below. And if this is by chance my first video that you've seen, this is all I do. It's all functional prints. There's no multicolored garbage of the week or anything like that. It's all design and functional 3D printed parts. So if you're into that sort of thing, check out some of my other videos. And if you like what you see, hit the subscribe button. And guys, if you do, I'll see you next Friday.